right, we are live now everywhere. How's it going, guys?
Good.
Good, thanks.
Good to see everyone. So this is Edge Impulse Hackathon Ask Me Anything session, third one. We only have 11 days till the end of this amazing hackathon. We already have a few thousands of people subscribe, and the submissions are already flowing. Super interesting submissions. So we are looking forward to see more submissions from most of you. Let's do a quick introduction because I don't know if we have new faces or not. You want to start, Jim?
Yeah, hi everyone, I'm Jim. I'm one of the senior engineers in the developer relations team at Edge Impulse. My background is in product design and engineering. I worked for Dyson for a number of years before I joined Edge Impulse. So I'm really excited to see in the hackathon what you guys all create in that kind of space. You know, what new product ideas can you come up with? What kind of systems do you think AI can help with in terms of human-machine interface and kind of intuitive design? I'm really interested in that sort of frame of reference. Anyway, excited to see what happens later.
Amazing. Owen.
Hey, so I'm Owen Jordan. I worked in HP doing mobile application services, creating concepts and proof of concept applications like at a fairly high turnaround. So a lot of different designs for applications for a while. And then I worked in IBM in network device management. And then I participated in a hackathon around climate change, Climathon. It was around the smart cities era. And we managed to get funding. I'd already done a lot of proposals and chased funding before, but on the back of our hackathon, it went so well that we decided to try and pursue it, and we ended up getting funding for it. So entering in these kinds of things are, you know, it could change the course of your life, really. Like, you could meet people on these hackathons that you end up working with in the future. And a lot of us know each other from participating in hackathons and things like this before. And I'm currently working in developer relations in the same team as Louis and Jim and Mark. And I'll hand on to the next person for their introduction.
Yeah.
Thanks, Owen. Yeah, so I'm Louis Moreau. I lead the developer relations team with Edge Impulse. So I've been with Edge Impulse for about 4 years and a half now. Before that, I worked in some cloud companies, so a French-based or European-based cloud company called Scaleway, and been at a few other startups. And before that, I was working on IoT projects at Sigfox. This is where I actually met Mark. Mark had a company at that time that used a lot the Sigfox technology, which is a LP1, low power wide area network protocol. So yeah, I've got plenty of experience with IoT, and I think it was back in a bit after COVID or during COVID, I got a lot interested in machine learning in general, like analyzing data, etc. So I did like the Andrew Ng Coursera specialization on deep learning, and I thought like when I had the opportunity to join Edge Impulse, like wow, this is the combination of the two words that I like machine learning and IoT. And now even like 4 years and a half, it's a lot, but it's a pretty short time, and you can see the capabilities of the Edge AI hardware that are all the new use cases you can think or you could have thought of before that it was not possible. They are now possible. I'm going to take maybe an example. Like one of my core projects at Sigfox was to connect rhinos, rhinoceroses. It was a non-profit project, and I had developed that small GPS tracker that was sending the GPS location to rangers and conservationists like 3 times a day. And at some point, like in the product evolution, I wanted to add some movement analysis. So if, for example, the rhino was not moving at all for a certain period of time, you would send an alert. Only like doing that through an accelerometer, you had to go through very complex decision trees and etc. That was almost impossible. I wouldn't say impossible, but the intelligence you would have to put into the algorithm was extremely complicated. And now this is like those kind of models can run with only a few kilobytes of RAM, consuming almost nothing of energy. So yeah, the Edge AI world gave you a lot of new opportunities to create your project that were not feasible a few years ago.
Yeah, that's That was an amazing project, actually. And did you participate in a hackathon, Louis, yourself?
I did a few when I was mostly when I was a student, and since I did a lot of hackathon as an organizer, but no, mostly when I was participating in hackathon, I was a student, and indeed I met a lot of cool people that I'm still in contact with as of today.
We ran a Sigfox hackathon as well. It was great. Sigfox were really good for doing hackathons back in the day. So much fun.
Absolutely, yeah, that was fun. Let's do a quick recap of what's the Edge Impulse Hackathon, in case that people don't know about it. So let me go. So this is a global virtual hackathon. It will last till the end of this month, 30th of November. And basically what we want to do, we want to see here from your applications, it's basically two type of projects. We have two themes. First one, it's Edge AI application track, which we want to see innovative solutions on real world problems that you can have or that you know that happen. So how do you apply Edge AI running on embedded hardware to fix that problem, or just apply creativity and innovation to solve a specific thing? This can be running on embedded hardware or on mobile phones or computers, whatever. We will get to this session today. It's focused on this theme. The second theme, it's a model development track. So we also want to see developers to basically develop and optimize machine learning models for audio, vision, and time series data from sensors, etc., to build great data sets that can be basically the foundation of Edge AI applications that can be built in the future by other developers or by yourself as well. If you want to know more about this track, basically you can go to our YouTube. We have the recording there from that we record basically last week. We were focused on this theme. And basically the timeline, it starts this month. We open submissions this month, and it will last till the end of the month. We don't have any specific deadlines for registrations or anything. You can submit your project by the last day if you want. But yeah, we recommend that you start preparing everything. We have prizes in cash, in dollars. So the best overall project, it's $12,000. We have best development, best model development, and best Edge AI application with prices of $5,000 cash. We have an impact award, AI for Good, with $5,000 more, and a student award. So if you are a student and you can register with your university email or your school email, you can actually as well get this $3,000 student award if your project is really good. And we will have special mentions. I'm sure we will send a bunch of hardware, goodies, and more to all the participants of the hackathon. So yeah, this is a bit of the recap. So first session on YouTube, if you go, you will be able to see how to document a project, to highlight, to have like an excellent project for us, because the most interesting part for us is the documentation, so other people will be able to replicate. Last week was about model development, and this one, it's about Edge AI application. Yeah. What's your favorite? What would you do if you would have to be on this hackathon, Jim, Louis, and Owen? Model development or Edge AI application?
I'd definitely be looking at the Edge AI application. What I most love about Edge AI is how you can build like a system that makes a real difference without it seeming like there's any AI in it at all. It can be very discreet, and I've seen it. I worked for a long time before I joined this team at Edge Impulse in the solutions team, where we would go out and work with real industry customers and help them develop kind of products and systems using Edge AI. And when I was doing that job, I saw a lot of different things, lots of kind of industrial efficiency solutions. But the ones that really interested me were some of the kind of products that we were working on, you know, things like smartwatches or rings, or even very prosaic everyday objects, you know, think white goods, washing machines, things like that, where Edge AI could bring a really small but effective kind of difference to the way that you interacted with the system. or to the way that you looked after the system. So detecting failures, detecting faults. I love all of that stuff. And if you can think really innovatively about, things like human computer interaction, I think Edge AI is a really great way to create kind of novel ways for you to interact with a computer. I mean, the original Edge AI use case is in the Alexa. So you might have an Amazon Echo on your desk with you. I've got one here. That's a classic example of an early Edge AI use case. There's on-device processing there to detect when you say that wake word, Alexa. And that's kind of one of those early ideas of how you interact with a new device more sort of smoothly. But there's a whole load of new stuff that you can do nowadays that is enabled by Edge AI. So yeah, I definitely do the Edge AI track, and I'd be looking maybe at that human machine interface area of the world. What about you, Louis?
Love it.
Well, I'm not sure because I love like the end application and the post processing. Currently, I'm like into robotics or robotic system. Like, by the way, I recommend this great book like AI for Robotics.
Wait a second.
So I'll
Show it again. Show it again. Oh wow!
So I'll probably go to the Edge AI application because it's the model itself, but also how you can act and do something after that. But on the other side, I love how to like optimize things at the maximum. So I think in the end, I might choose like the model development because from the dataset pipeline, like you can collect plenty of things that are specific to your use case. You can optimize the model, and then the goal for me is to be able to run on the tiniest object or tiniest microcontroller. So yeah, I'll probably go with a more research and development track, like on how to optimize the models. But like the robotic applications could be interested as well for me. Owen?
That's really cool. Owen.
Yeah, so I'll just try and go, I suppose, for a similar, maybe I'll think about, so I'll try and just go with a different angle here. What I'd probably try and do is take my domain expertise. So if I'm a physiotherapist, or if I come from, like I had started my background in civil engineering, and I'd learned some principles around how you can do estimation of housing, basically the area of a house from just measuring pieces of the front of the house, like the windows and things like that. So I probably try and build a model around my domain knowledge. So if you've got a background in physiotherapy and you've got intuitions about how signals or how gaits of a person or how facial expressions are related to certain conditions, they could be stress, they could be activities. I'm just thinking in the physical sense of things. So we have kind of two tracks. It's like human health, machine health. And I would probably go down the human health route if I was a physiotherapist and I wanted to look into something like that. If I was more coming from a mechanical background and a civil engineering background, I'd probably look in the machine health route. And I try and see how I can apply my domain knowledge around how machines operate and the conditions that are important to the outcomes, and try and build a model either vision-based or sensor-based within my skill set.
That's a really good point, Owen. I think it's always important to remember that Edge Impulse as a tool was created to help enable people with certain domain expertise, but not necessarily expertise in data science and machine learning, to be able to take that knowledge and turn it into a machine learning model. I mean, our founders were embedded engineers, and they had deep domain knowledge expertise around that field. And they saw Edge AI as this really useful potential tool for enhancing what they do. And we've seen that expand out into a really wide range of different fields. So I think that's a really nice way to think about this hackathon, because it's open to everyone, and hopefully our tools make it easy for anyone to pick up and take their domain expertise and turn it into a cool project. That's really cool.
Thanks.
Absolutely.
And what about the like AI for good initiatives? Like I think Owen, you worked on something like that in the past around like the
I got
detection, right?
Yeah, it was a really amazing project. I got to help out with the AI for Good project, which was just really inspiring. It was this initiative that a researcher created based on a film that he had created, Andrew. It was around rats' movements being able to. So, okay, rats can sense and smell landmines, and they can be trained to do these certain body movements when they detect them. So this activity, so this movement that they make was what they trained their model on, and they had this backpack that was on the model, that was on the rat, and it was a really wild project, but it was so cool to be able to help out a little on that one. And yeah, I'm glad you reminded me of that one because that was so cool.
That was super cool. And then
we had two models on it as well. Yeah.
We had a few of our colleagues as well who went to, I think it was Kenya, to work on an elephant conservation project, and they came up with a new kind of solution to detect, or at least to identify the elephants. It was like the elephants, when you take a picture of them, like they have the same thing as we have on our fingerprints. Like you can create kind of a fingerprint around the eye. And this knowledge was brought by knowledge expert and conservationist. And so they took that knowledge and they made a machine learning model on top of that with some kind of pre-processing steps to only extract like the key information point. And they were able to identify like the rhinos only with a picture. So that was astonishing. I think Sarah wrote a blog post a few years ago, maybe 2 years ago, around this project. So I'll try to find it and I'll share the link.
Awesome. Yeah. No, totally. And by the way, people who's watching this, please ask questions in the chat because we want to answer questions in case you have. If not, we will be chatting. And actually, I found by serendipity this project on Hackster. Wow. I found it interesting. Actually, LoRaWAN and fertilizer pollution just get my attention, but then I realized it was using Edge Impulse, and it's pretty interesting as well. And I thought maybe this can be part, if this is made by an expert network. I realized afterwards, but yeah, that could be as well an interesting and very complete and very well documented project actually.
It's an interesting topic. The fertilizer topic. I live just behind me. There's a river, and York is a place where I live, where they have the highest amount of river pollution in the country. So there's a lot of surface runoff from fields and farming, and also sewage being pumped into the river when it rains. So perhaps that's an area I'd have looked at if I was doing. Actually, I did a project a while back looking at predicting river level rising on this river. It's on the blog, but yeah, something to do with kind of detecting pollution in rivers. That's an interesting point. One of the things you can do really well with Edge AI is to basically create virtual sensors from much cheaper sensors. So it's quite an interesting approach to look at. Can you take something really cheap and off the shelf, like some environmental sensors combined with, conductivity sensors, things like that, and use it to emulate a much more expensive sensor? So that would be something I'd be really interested in exploring, because something like river level pollution or river pollution is very hard to detect, and it takes very expensive sensors right now. But could you look at maybe applying cheaper sensors to get a slightly less precise but still useful kind of level of pollution, for example? That's an interesting topic.
This is actually the techniques that is used to detect sleep patterns and stuff like that. The way you train the models, usually you just focus on either PPG sensors or accelerometer, and you combine that with a kind of medical grade devices, at least to gather the data set and try to find the patterns. And then you train your model to kind of emulate what the medical grade sensor is like. So, and then you can run your algorithms to detect sleep, or it could be something else.
And just in case anybody's not aware, it's sensor fusion we're talking about here, right? Sensor fusion, right? And
so sensor fusion is definitely one of the approaches you can use to make much more powerful sensors. Sometimes it can work with a simple sensor, just a single PPG sensor, for example. But yeah, sensor fusion, where you're combining different modalities of sensors as well, is a really interesting approach. That's something I'd love to see in that model track. Is some people doing some more novel sensor fusion, combining different types of sensors for sure.
And we've got data normalization now as well, which is a pretty recent addition as a feature. So it should make those models even better in theory.
Yeah.
Just when I was testing some of the previous data sets that we had, I noticed that we had a pretty significant increase from just enabling data normalization, which was pretty cool to see.
Yeah, I mean, that's a really good point. A good tip for if you're developing a model. Normalization is where you scale all of your data from, I think, between 0 and 1 in the case of our system. Quite often with sensors that you have in Edge AI fields, so think about an accelerometer sensor, there might be a certain scale that it has. So it's from 0 to 5,000. And if you're trying to combine that with another sensor that only goes from 0 to 10, then neural networks will generally bias towards the larger number. So being able to normalize all of your data to the same scale means that you get a lot more of the pattern matching from those two different sensors. That could be a really interesting approach. And that's a sort of gross simplification of it, but yeah, a little tip there for you, worth looking into.
And is this across the whole data set, or it's the normalization is done on the sense or on the sample level?
It's on the features.
Yeah, it's done at the feature generation step, so I imagine it's across your whole data set.
It's a really powerful feature. It's very cool. Actually, we've got if I pinged the link for the doc in, and there's two tabs there where we can see before and after. So if you just if you scroll down a little bit, you should be able to see how dramatic the increase is. 94 to 99.1. That's on our sensor fusion example.
Very cool.
And back on the model, not the model, but actually the project track. Jim, any cool? What's your favorite projects like you've worked on in the past?
Well, I can't talk about a lot of them. There are some really cool ones that I've worked on that are secret from companies that you would know. But let me think about what's public. There was a really interesting project that we did with a vehicle manufacturing company where we were looking at doing some pretty simple stuff on their production line, but that was able to really drive massive increases in efficiency. And I loved that because it was some people taking their domain expertise in understanding, okay, these are the kinds of failures that we see on this production line. And these are the areas where we have massive slowdowns because if stuff gets through, we have to shut the whole production line down and we have to take the item off manually. And that's often, I think, where a lot of this kind of extra intelligence can bring a lot of value is in systems that are already quite highly automated, because a highly automated system that has a small failure that involves needing human intervention suddenly negates all the benefit of it being highly automated in some ways. So I loved that example because it was, I think, every time a part it was something as simple as mislabeled. When it got to the other end and out to the customer, they were charged a crazy fine, and it was happening pretty regularly. So being able to then take that, a really simple machine vision model to detect the different labels and tell you, okay, does this label match to this part? It was a really simple idea, but it was able to create really massive, really quick sort of business value. And that's actually a really good point. That's something I wanted to touch on today about the Edge AI use case, is that if you can think about when you're writing up these use cases about the kind of real world value of what you're doing, I think that's a really great way to frame your project. Something that I always did when I was convincing these customers to use our platform is we would dig into, okay, you have an idea for how to solve a problem, but let's go beyond that and go, okay, you have the idea. What does solving this problem actually do for your company, or what does it do for the world? And in the AI for good setting, I think that's also a good one to think about. think about the real value of what you're doing and work back from there. Because if you can boil it down to what the actual kind of benefit to the world is, or the benefit to the company is, it makes it a lot easier to then scope out the problem and make the problem really efficient and simple. Because there would be a tendency to go, if you just came into that example use case in the factory floor to say, we want to apply AI to this industrial process, then you'll massively overcomplicate it and you'll create a really complicated system. But actually, if you think, oh, actually, the real problem is that we're getting these massive fines, and the only reason we're getting these fines is because these stickers are on the wrong parts, then we just solve that problem. It creates the most value really quickly. So yeah, that's a little example that I would sort of say was one of my favorite to work on, because it was such a kind of clean idea.
And just for my curiosity, like without saying all the names of the company, etc., but that was like a kind of a camera mounted directly on the conveyor belt or in the production line.
Yeah, so that's actually a really interesting point. Thinking about how you sort of scope out the physical environment in which your model's going to work is really important. So, sometimes I've gone to companies that work in the manufacturing space and they go, again, we want to have AI in this industrial environment. Our idea is that we're going to have each of the workers wear a camera on their chest and walk around the factory, and it's going to do the AI. That's a really cool idea, and you can imagine how that could solve a bunch of different use cases. But as soon as I see that kind of thing, it immediately gives me red flashing lights, because that increases the complexity of the environment in which you're working massively. You're adding many degrees of freedom because the person can move in any direction. And every time you add a degree of freedom for an image model, you need to collect 10x more data. So what we did was,
right?
Yeah, exactly, because you don't know what it's going to see, and maybe it gets used.
Toilets, kitchens.
Yeah.
And
privacy as well. Privacy is a really important point. So what we often did was we would go, okay, that's a really interesting idea. Let's think about the problem we're trying to solve. How can we scope that down? And if it was as simple as, okay, let's make sure that this camera is overhead, often on the production line, and even to the level of, okay, if we want to get this to market quickly, if we can make sure that all of your parts are always in a fixed orientation, then we know for sure that the result from this model is going to be much more accurate, because there's just less variability, and we can collect a lot less data and get to market quicker. And often it's not about collecting data, a small amount of data, because it's boring or you don't want to. It's about collecting a small amount of data because it's really expensive to collect data in a factory setting. If you have to shut down a production line, install a camera, and then collect a bunch of data and go back and collect more later, that can add a lot of time to the system. So if you can be really efficient about setting up your environment so you don't have to collect much data, it can create a much more robust model in the future that works in the real world. And the same applies for time series models as well, and audio models. If you can really scope down the inputs and outputs, then it becomes a lot more.
And what is the real value of having that processing done directly on the camera rather than in the cloud? This is often a question that we hear from prospects or customers, because all factory floors are connected through internet most of the time.
Yeah, so in a lot of cases, it's about reliability. So on a production line, you don't want anything on your production line relying on something like Cloudflare, for example. This week we've seen, or AWS, because a small outage can have massive knock-on impacts. And then there's also just the case of, for a lot of these companies, what they're really looking to do is to create discrete systems that just work. So if you have a system that is constantly needing to send data up and it becomes an operational cost, it's a totally different thing from what is effectively like a tool. If you think about it as a tool or a machine in a factory that operates on its own and is just a part of a bigger system, it's a lot easier to think about that as something that you develop and then you kind of perfect, and then you leave there and it works really well. A lot of these companies, though, will also have a hybrid approach. So a quicker way to market often is to think about your device, version 1 of your device, as a kind of hybrid device, which is going to do some processing on device, but is also able to send that data back up to something like Edge Impulse in order to make your model more robust in the future. So if you can send that data and what it's done back up to the system, you can then use that to iterate on your model much more quickly. And then in the future, you can scope down and make your device kind of further out to the edge, and remove the connectivity if you need to. But often that's a much quicker way to market than trying to go to the very end and very edge at the start.
Yeah, usually we say that every single machine learning project or edge AI project, I think it applies basically for machine learning. It's really an iterative approach. You test first with a smaller model, or with the first, like your first samples. You test it, you'll start to get some immediate results. Like they won't be perfect, but at least you'll get some result, and you will be able to collect more data that are already pre-labeled. It needs to have a validation, etc. But this is part of the overall active learning loop. So you keep on retraining your model with new data that has been added. And this can help you to save some time to go to market. First, you go to market with the first iteration. And then over time, like after a few iterations, you will see directly the progresses of the accuracy and robustness of the project.
For sure.
So, yeah, and I like your idea of don't try to solve everything. No, just try to find like one pain and try to solve that problem first. No, and then go to the next one.
I think that's really also a great way to think about this hackathon, because there's only a week left, but there's still time in a week to show us
2 weeks,
a really small but effective solution to a problem. So there's still time to start today if you have a good idea to solve a small part of it and really wow us, because often the kind of integration hell is how you spend most of your time, but actually that first bit of just proving the idea can happen really quickly.
Yeah, exactly. And how do you think if someone wants to participate and don't have a clear idea, so what would be your recommendation to start?
I think that there are two approaches.
All you three, yeah.
Sorry, I'll start quickly. I think Owen's touched on one, is think about your domain expertise, and then the other one is we have a massive repository of example projects in our docs under the expert network area. I recommend just reading through a few of those and thinking about the different sensors that maybe you have with you. I always start with the sensors on a smartphone. It's a really good place to start. Just start playing around. You've got accelerometer, microphone, camera on this sort of thing. That's all you need to start developing and deploying models. So just have a play around. But I don't know about the others. What do you think?
Well, I was going to say, maybe, I know we're speaking really about controlled environments and closed systems here, but we also mentioned robotics. So probably robotics would be a very open system, open world one. How could they do that in a controlled environment? What kind of robotics projects would you anticipate or think, Louis, that would fit within this kind of scope of a project? It'd be interesting to hear.
Yeah, well, for me, given the timeline, I think robotics projects sometimes it's a bit complex, especially on the end. And unless you really have a domain expertise in robotics and you already have kind of robots ready to go, and you want to switch the model with something that is smaller, faster, etc. For me, I would just pick a project from the expert network or from the /project page, which is not fully. It shows the model what it can do. And I would pick something like that and do some further steps. So, for example, like send the inference results somewhere, which can give some benefits, some additional benefits, or combine that with another system. I think this is a great way to start. Pick something that does already exist and try to make it useful and for your use case and for your domain expertise. All right, so I think we don't have many questions on either the chat or Discord. Mark, do you have any other final words maybe you wanna share, or?
Yeah, no, I wanted to extend your answer actually, because Brian had a very good idea on Monday, and I wanted to share it here as well for people who's here today. And it was about maybe if you don't have ideas, you can go to our project list from the expert network and just try to get one of these projects and try to continue or try. One of the concepts that we are working these days, it's on model cascading as well. And I love this concept of having one Edge AI or one machine learning model that basically triggers a second machine learning model or more or other type of AI systems. And with Brian, we were brainstorming basically of, okay, can you get to work any of these projects from the expert network list, and basically from that foundational starting point, just add something else that can be triggered by the previous machine learning model. And I thought that was a really good, a really interesting approach. And we were talking as well about something else, like maybe you are using today already digital products that can have APIs. Why don't you try as well to increase the functionalities of your favorite products that you are using today, taking advantage of the data shared through the API, or maybe that you can interact with it, and adding Edge AI applications on the top of these products, basically add new functionalities to the system. And for this, for example, I wanted to highlight one of the projects that Owen made for the Maker Faire Rome in some weeks ago, where basically, you train a machine learning model to detect when the printer was not performing well during the printing, right? What it's called is a spaghetti printing. To when it was detected, basically send an API call to the REST API from Octoprint already connected to the 3D printer, and stopping the print, right? I think with this, you are amplifying the powers or the features of a 3D printer, and just using a product that's already existing.
Maybe you would like to come back to the model cascading. I think, Jim, if you can explain a bit what you've been working on for the car parking slot demo. I think this is a really cool use case on how you can leverage Gen AI models, but still don't run it all the time, because it will be extremely costful in the end. Jim, I'll let you speak about this project. I think it's an awesome one to explain the model cascading.
Yeah, I think there is a blog about this somewhere that we can maybe pull up. Here we are. Perfect. So this is an interesting model that I worked on last year, and obviously, or earlier this year, rather. Obviously, right now, generative AI is a really big topic. For the edge, I think we're yet to see how it becomes really powerful. And we're working on some stuff at Edge Impulse. You'll have seen maybe at Imagine that we announced some new tooling around kind of basically a prompt engineering tool for running Edge AI models that are generative. The problem that you have with something like a small language model or a vision language model that is small enough to run on even some quite powerful hardware is that compared to ChatGPT, which has 1 trillion parameters, these sorts of models have maybe 1,500,000,000 parameters, and they're just not very reliable at responding accurately to what you ask them. So you might have a fairly simple use case like we have here, which is a model system that is going to detect cars that come into a car park and then tell us a few different things about those cars. So the manufacturer of the car, what type of vehicle it is, what color it is, maybe its number plate. And you'd think, okay, it's really easy to do that with ChatGPT. You just send it a picture and say, tell me about all of these cars and give me all of these results. But actually, these smaller models are really not very reliable at that. So one of the things that we can do is use model cascading, which is multiple different layers of models, to give us the power of the generative AI model, but also the reliability of a traditional model that you might train in Edge Impulse. So here, in this use case, we have cars coming into the car park and parking, and we're taking a picture of them. And then firstly, we're passing that to a traditional object detector. So the object detection model is trained in Edge Impulse to detect vehicles. And then we're taking the little bounding box around each of those vehicles, cropping out the vehicle itself, then only sending a picture of the car that we know is a car to our on-device vision language model, our on-device generative AI model, with, again, a specific prompt that asks for exactly the color and the type of vehicle and the manufacturer and the number plate. And with that approach, you get a much more reliable result, because you can tell that VLM, I know that this is a car, only tell me about this car stuff. And then you're massively restricting the amount of context that it has to deal with. The other interesting thing here is that we've also looked at using structured outputs for these large language models. So traditionally, when you're working with ChatGPT, it's in a like chat window, and it's basically a natural language that it's giving back to you. But I don't know if you've ever asked it to give you structured outputs. So asked it to respond in JSON format in a certain way. Sometimes it really struggles with that. There are new tools available now which kind of form a grammar system around the model, and it will basically keep retrying until it actually gives you like a valid JSON output. We use this in this demo to make sure that the output of the model was only ever like a structured JSON kind of dictionary with, you know, car type, and then the car type, and then color, and then the color, and then manufacturer and the manufacturer, and things like that. That's a really important thing if you're going to actually use this kind of generative AI model in a real system, because you need to be able to then create application behavior around the response of the model. It's really easy if you have a traditional model like an object detector, because you know that you're going to get the class and the location data every time. But if you have an unreliable kind of actor like an LLM in your system, it can be unreliable. So yeah, using that grammar system can be really important for getting a structured output. And then, yeah, what you see here is a kind of whole model cascade that is able to run at full speed real time. So we're constantly detecting new vehicles at 60 FPS, and then we're only passing to the much slower on-device small language model, vision language model, when we see a new car. So we're doing object tracking on that original data first. So we've got a really quite complex cascade of quite simple to develop parts that makes a much more powerful system. Whereas if you tried to just brute force it with just the vision language model, you'd need much more powerful hardware to run it at 60 FPS, for example. And you'd need much more powerful model, like a cloud-based model, to get the accuracy that you required if you sent it a picture of every single car. So yeah, the real lesson with this kind of use case, and this is quite a complex one, is that it's often much easier to combine 2 or 3 smaller cascading simple models than it is to try and brute force it with one big one. And actually there's a AI for good use case which is really interesting that we've worked on, that Louis was talking about, which is we worked on a camera for tracking wildlife in the field, and wildlife cameras need to have a really long battery life. So you can't run something like object detection all the time in order to get kind of what animals are there. But what you can do is do model cascading on that device and run something like an audio detection model to listen for, this isn't quite the right one. I'll try and find it later. It was Conservation X Labs we worked with on that camera. But basically, the device had a microphone and a really low power microcontroller that could do audio processing continuously and listen for the sound of the animal, and then wake up and take a picture and see if it was the right animal. That kind of model cascade, or even something as simple as using a PIR sensor as the first step. So, you know, waking up when you see motion and then running the model. That kind of approach where you're using a low power thing and then a much higher power thing was able to create a system that is able to last a lot longer. So there are 2 different ways that you can win with model cascading. One is in kind of architectural design to make your like actual device last longer in the field, for example. And then the other is in kind of reliability, where you use a number of different models to make sure that the result is really reliable and trustworthy. So yeah, really interesting 2 different approaches there to get the kind of different efficiencies from small and large models, or from on-device hardware.
Really good example. So Jim, are you saying that you think that entries would be able to achieve this, or would this be like a future work and architectural type example for the project? Sorry. I
think you could definitely talk about it as future work, but also, I mean, I've done this fairly simply with, you could look at passing as a prototype, having your first stage Edge Impulse model, and then passing up to a generative AI model in the cloud, for example, as a kind of proof of concept. That's totally achievable, very simple to kind of create and demonstrate. So if you wanted to, but I think it's key to say that what we want to see is a model trained in Edge Impulse is core to the system. So it's not going to impress us if you just send some sensor data up to ChatGPT. We want to see that thinking about the reliability factor if you're going to use something like a vision language model, and thinking about that architecture that makes it really clear that, you know, the multiple models are really important.
Just maybe stepping back a little bit then from the LLM side, you know, you could like use your keyword spotting one to invoke something else, like you did with the, you know, there's the fun demo that you did with the Mission Impossible tape. Obviously, it didn't trigger another model, but it triggered something.
Yeah, that's a really good point. Yeah, using models as a trigger for something is a really interesting point. And then also the other way around. So using something like a simple sensor to wake up your system and then run the model, I think is also a really valid way to think about this kind of architecture of your model system.
And going back to the VLM, I wanted to connect as well with what you said at the beginning, no? That it affects the human-computer interaction.
Yeah.
So I think this can create a lot of new ways to interact with machines, right? When we will have these tiny, multimodal, large or small language systems, models running on edge devices. So where you will be able actually to ask, hey, what's the color, or what was the license of the last car who arrived to the parking lot, or things like that, by voice, and then get exactly that for a specific format answer.
And that applies as well for other use cases. For example, you could detect simple defects and then ask for something that is more intelligent, like what kind of defects it is. So you can then interpret that. But you don't need to run that all the time. You only run that once you detect a defect on a production line or something else.
What else? I think we are good. We don't have any questions here. I don't know, last recommendations that you would give to people to submit their projects on the Edge Impulse Hackathon. What would be your recommendations?
Just get stuck in. Go and
we lost audio.
Start up. Audio? Oh, no?
No, I can hear you, Jim.
Yeah. I would just say get stuck in, boot up Edge Impulse, get your phone out and start collecting some data. I mean, we talked about that really cool use case last week of the table tennis bat with the sensors in it. A really simple kind of way to create something like that is tape your phone to a table tennis bat and go and have a play. That kind of thing is as simple as possible. You know, this is your kind of key to getting a prototype done. I would say it's got everything you need: a battery, accelerometer, camera, audio. So if you don't have any ideas yet, just start thinking about your hobbies. Think about where you could stick a phone and collect some data and see what you can create.
Yeah, and going to the phone before everyone else add their answer to my question. So, for example, now we had this project from X4 Networks of snoring detection on a smartphone. So actually, you don't need any hardware. You just need to train your machine learning model with your phone and just run this model as well on your phone itself and get the results that you expect. Sorry for the interruption. Louis, what are your recommendations?
Yeah, I was going to mention the same, like don't feel like the data collection should be a blocker, try to find a way to simplify it. If it's really like complex sensor, etc., well, in that case, it might take some more time. But most of the time, like with a sensor, with a smartphone or a simple like Arduino board, you can get things up and running pretty fast. I remember once I worked on so I've got a grinding coffee machine, and it makes kind of a weird noise when there is no more coffee beans. And I wanted to detect that, so I just put my phone on the directly on the coffee machine and just capture coffee after coffee, like the sound. And at some point, I had enough data to just train a machine learning model. It works very good. Like this is a simple use case, and for me, it had a direct benefits because I knew beforehand. I kind of ran a regression model, so just before it was completely out, I could detect it and refill the coffee. That was a kind of a personal use case, but just to say, like you can apply these like concepts to things in your house, and in your kind of description, you can apply that to a more industrial use case. You don't need to show like the full working project. It can still be a proof of concept, but put that in context with a kind of a use case that could be interesting for a broader audience or broader industries.
We have a question on LinkedIn.
Idea. Oh, go
on. No, sorry. Yeah. So Atilla is asking, can one project apply for different categories if it fits in multiple tracks? So just to remember you, Atilla, we have 2 tracks: model development and Edge AI application. Okay, but it's right. So you can build, you can develop your own machine learning model and build an application on the top. If that's the case, I'm happy to see how can we apply in both tracks, and we can, But you have 2 weeks actually to document everything and prepare the submission. So as my colleagues mentioned, my recommendation is just submit one of the track, one of the projects, and then focus on the other one. But try to submit something early as possible. Or do you have any other recommendations for Atilla?
Yeah, I would just be keen to see like a really clear differentiation between your documentation for the model and then the documentation for the application if you're going to try and apply for both. We want to see a clear thinking about the model development and then a clear thinking about that AI edge application. I just wanted to say Louis' idea brought up an idea that I've had for a long time. I've wanted to do. I have Home Assistant in my house, the little local-based smart home system. And I've always wanted to have a sensor on my door that could detect when someone knocks on the door and then ring my doorbell. I have a button at the moment, but it always seems like people never press the button. They always knock. So that's something I'm going to try and do later.
That would be a fun use case. And I was thinking about something like there is an application on smartphone which is called Sensor Logger. That can, so it's not directly connected to Edge Impulse, but it can save in CSV formats like plenty of things from your phone sensors directly to a CSV. I think there is even a subscription that you can take that could send that to the cloud. You don't necessarily need it. Once you've got it, you can send it away and parse it. But it's also a great way to collect data like in a longer time format, for example, for an hour or for 30 minutes, and then you can extract that to push that then to Edge Impulse.
That's a very good idea, yeah. Owen, what would be your recommendation for participants in the hackathon?
My audio, I hope you can hear me.
Yeah, we can hear you.
Okay, yeah, I can just hear Mark for some reason. It's strange, but my advice is just get a submission in. If it's your first time, don't be shy, get it in, enjoy it, get your name in there, get a submission in, try and do your best effort obviously, but enjoy it, meet people, and look forward to the next one. Just get in there. Yeah, I'd say get a submission in, don't hold yourself back, apply your domain knowledge like we were saying, and just have fun. Yeah.
Just added here the URL of our Discord at Edge Impulse. So if you want to find someone else to work on this hackathon, or you want to ask any questions or anything, just sign up in our Discord server. And here you have the URL to register to the hackathon. And my recommendation would be to basically document very well your project and explain a compelling story that where we can think, oh wow, I need that as well. So I want to test this project myself. And I think if you can get that feeling from people who will read about your project, I think that's a win. Even if you don't get any award or anything, I think that's the most interesting thing, that people want to test your project, and you had the right instructions and the step-by-step to enable anyone to just deploy your project in an embedded device or mobile phone or whatever. And that's it. I don't know if we have any questions on Discord. I don't think so. People on Discord are very good today. Don't have any questions. So I think this is it, right? We gave
Thanks
many tips to people.
Thanks, Mark, Jim, and Owen. I think it was a great conversation. I enjoyed it.
Yeah, interesting discussion for sure.
Have a great week, everyone. Work on your project, and feel free to ask any question you have on Discord directly. Our team will be monitoring the Discord, and we'll do our best to answer your questions. Have a great week. Bye.
Bye, everyone.
Bye. Thanks for attending. Bye.